अमित और मैंने ही
So
की थी
today,
बस।
okay. So today we are going to make a circuit, okay, of two input NAND gate. Basically, we'll be making this two input NAND gate using the devices which you have fabricated. Okay, in our last session, we have seen how to make a NMOS and PMOS using your design rules. So here I have taken this NMOS and PMOS which we have designed. So these will be using to make a NAND gate. So the circuit which we are going to make is a two input NAND gate. Okay, you could see the circuit. Okay, now could you see the circuit?
Yes, ma'am.
Yeah. So this is a two input NAND gate in which this is the VDD connection. So beneath that we have two PMOS which are connected in parallel. Okay, and here we'll be taking the output line. Below that, in the series connection, we have two NMOS, this NMOS 1 and NMOS 2. Okay, so here we are not at all considering about W by L ratio. We are just making a circuit with all the same similar ratios and a simple two input NAND gate where the gate of one of the NMOS and one of the PMOS has been shorted and being connected to a supply clock which is named as A, and another PMOS and another NMOS is shorted and being given as the second input of NAND gate, which is another type of a clock, and it is being named as P. Okay, so this same connection we have to make it. So the same connection, for making the same similar connection, we will have to place our circuit, that is our screen circuits, in the fashion shown in the diagram. Okay, so similar connection I will be using. So look at the screen. So the both of your PMOS, I will be placing both the PMOS in parallel. Okay, so I've selected this PMOS, I've kept like this. Okay, then I will be selecting another PMOS. I'll be connecting like this. I'll be keeping a minimum distance so that both the PMOS should not violate any design rules. Okay, after that I will be keeping this NMOS in series. So likewise. Now, the placement, like both the PMOS I have kept in parallel and both the NMOS I have kept in series. So similar fashion you can see on the microwind screen that I have done all the connections. Now I will be doing connection after the placement. First of all, what we'll be doing, we will be making this as common. Okay, so for that, with the same time, I'll be making this short connection. So look onto the screen. So I will be stretching out this metal outside. Okay, likewise, I will be stretching out this metal again outside. Okay, after that, I'll be stretching out the NMOS metal. Okay, now I'll be taking metal one from the palette. Okay, now I'll be connecting all these with this metal one. Okay, so this is the first connection which I have made. I have shorted both the PMOS and connected with one of the NMOS. Now the another placement is I will have to short another two ends of the PMOS. For that I'll be using stretch. So I'll be taking both another excuse me. So what I'll be doing, I will be stretching the another metals over here outside. So similarly this one. Okay, in the similar fashion I will be taking metal one and I will be shorting these two connections. Okay, so again look at the diagram. How much connections would have done? There are the connection which I have done are I have shorted this two ends, I have shorted these two ends, and I've done this connection also. Now the connection which are being left are shorting this thing. Okay, so again look at the screen. So I will be doing one of the connection. See here, one of the end is shorted upward, one of the end is shorted downward. So on the screen, whatever connection we see, this end I have shorted upward. Since so, I will be shorting lower end with one of the NMOS connection. Likewise, so I will be stretching out this connection. So I have merged this thing. Now this and it is open. Here I'll be placing ground. This and it is open. I'll be placing VDD. So from the palette, you can see. So here you have a VDD. You take it and place in or another top pan. Okay. After that, what do you have? You have to take the ground from the palette. Take the ground, okay, and place it on open end of the NMOS. This is the open end I'll be keeping over here. So just wait, I'll have to take a ground. I have taken another one. So I'll be taking ground. Okay, so taking the ground, place it over here. So I have placed this VDD, I've placed this ground. Now I'll have to take a output from the shorting line. So I'll be keeping a label over this common connection. So from the screen, I will be taking a label. The label is named as A. I will be taking that and keeping on this short line, which is being connected with both the PMOS and NMOS. I'll be keeping this thing. Okay, so its name is out1. Okay, and if you want to see the output in the screen, okay, in the simulation, then you will have to click visible mode. So it will be showing visible in simulation. Then assign. So your output is kept over here. Okay. Now the things which are been done till now are that all the connections are been done. I have placed VDD, I have placed ground, I have placed output. Only the connection which are being left are keeping clock cycle A and keeping clock cycle B. So to avoid extra metal layer, I will be taking the similar clock cycle for both the ends of NMOS and PMOS and naming it as clock 1. Okay, you can also do that. You can short the polysilicon. So that can also be done. So I will try to short both the polysilicon. So what I'm doing, I'm stretching out the polysilicon. Okay, I'm taking it outside Okay, and this polysilicon I will be shorting with the another polysilicon. So from the palette, I will be taking a polysilicon. I will be connected this polysilicon of NMOS, and with I will be connected with the polysilicon of PMOS. So this connection we have done. Okay, likewise, this polysilicon and this polysilicon has to be shorted. Okay, so we'll have to avoid any connection of this polysilicon with metal. So we'll not be stretching out from this side, we'll be stretching from upward side. Okay, so again from stretching, I will be stretching out my polysilicon. I will be stretching out my polysilicon outside. Okay, now again, it can be done very easily. So from the palette, I will be taking polysilicon. Okay, all the polysilicon I will be doing taking out like this, and again taking the polysilicon. So these are the extra polysilicon or metal line which we are using, and this extra polysilicon can give you some of the unexpected output. Okay, so it is the designer's responsibility that they should take a very reasonable amount of metal, extra metal or extra polysilicon what they are taking. So this is for just practice what type of connection we'll be seeing, which type of NAND gate we are seeing. So all the things we have done properly. Now only the two most left most things are providing the clock A and clock B. So for that input I will again go to palette. um, we'll be seeing clock. So here is the clock. So I will add a clock. Okay, I will be placing that clock on any of the polysilicon. Okay, and I will name it as A. Now, since my signal name is A, now it's all the dimensions, that is load level 1 is 1.2 volt, level 0 is 0, rise time, fall time, load time, high time, everything has been defined. You can increase the speed of a clock or decrease the speed, make it as faster one. You can make it as fast, you can make it as slow, whatever you want to do it, you can do. But remember to make this signal visible in the simulation and assign. Similarly, we'll be putting another clock which should be somewhat different as compared to your clock A. So I'm keeping clock, I'm naming it as signal B. Okay, and I am making this clock a bit faster as compared also, sorry, a bit slower as compared to another clock, so that we can see a difference in the output. I am making it as visible in simulation and assign it. Okay, so once you have done all the connections of the circuit, VDD, ground, input, output, and all the connections are quite clear, you can check for DRC. I will be checking for DRC whether some error is there. So my circuit is saying no error. So I will just run my circuit. So this thing I told you in my last sessions also, to avoid latch-up, we will have to polarize your wells. So here we haven't placed VDD in the N well, so that you will have to do, otherwise there is a risk of damage. So it is showing one of the warning. So I'm saying polarize with anvil to VDD. So what it will do, it will directly connect VDD over the anvil or both the anvils, and polarize with anvil, selecting that option. And here you can see the output on the screen. Okay, so here is one of the clock A, here is one of the clock B. You can see that when you're in the NAND gate, both the inputs are 1. In the NAND gate, both the inputs are 1. See, here A is 1, B is 1. At the time in the NAND gate, your output is 0. The same thing which I am getting for one of the input is 1 and another input is 0. For all these combinations, you are getting an output as 1. Okay, so likewise, you can check your circuit whether it is working properly in the simulation. So this is just a first cycle for which you are getting some of the errors. Okay, after that, all the outputs, they are being expected output, and they are similar to your theoretical outputs, and you can check your circuit. Likewise, you can make your NOR gate also. So today we have seen how to make a NAND gate using all of your fabricated devices. So what we have done today, we have taken two NMOS, two PMOS. We have connected both the NMOS and PMOS in a NAND gate type of structure, PMOS in parallel, NMOS in series, and we have placed all the inputs, VDD, ground, and the output, and we have seen the result in the simulation. So today you will be doing this practical and will be seeing the results. Okay.
Okay, ma'am.